Hi everyone, this is Dhanasekaran, Assistant Professor, Department of ECE. Today we are going to see about serial data transfer in 8051. Let's see. These are the outlines of today's discussion. So first one is the basics of serial communication in 8051. Registers used: SCON register, that is a serial control register; SBuffer, serial buffer register; PCON, that is power control register; and finally we're going to see about baud rate generation. So before we going to know about serial communication in 8051, we should know about what are the methods of serial communication. So in serial communication, if you look at the internal communication of microcontroller, it's usually parallel. The parallel communication sends multiple bits of data simultaneously using multiple wires. So in the case of 8051 microcontroller, the communication involves transfer of 8-bit using a data bus. So it needs 8-bit wide. In the parallel communication, definitely the fast but requires more connection. This leads to higher cost and hardware complexity compared to serial communication. So then only we are going for serial communication. So therefore, for long distance communication, the communication outside the microcontroller, the serial communication is preferred for choice. Serial communication is the process of sending data one bit at a time over a single communication channel. The method of communication reduces the number of required connection, lowers the cost and complexity of circuits. So it allows communication over long distance with minimal signal degradation. So microcontroller converts the internal parallel data into a serial form. Then it transmits over one or two lines, one bit at a time. When microcontroller receives the serial data, it converts the data into a parallel form, so that the internal data processing becomes seamless. And we have, as I said, we have methods. One is we can divide the serial communication into two primary modes. One is synchronous and another one is asynchronous. In synchronous communication, uses the shared clock signals between the sender and receiver to coordinate the data transfer. So both devices stay in sync because the clock controls the data timing. So hence it's called the synchronous communication. This method allows faster and more reliable compared to asynchronous the data transfer with precision timing. And this is suitable for high speed applications like memory interfaces and display connections. Whereas in the asynchronous communication, it does not need rely on the shared clock signals between the devices. It uses start and stop bits to frame each data byte and define the beginning and end data transmission. So it starts like a start bit and it ends like a stop bit. So once the transmitter sends the data, it identifies the start bit and identify the stop bit. It will transmit it to the receiver. So both devices must agree on the baud rate before communication begins. So in the last slide we will see the baud rate and all. So these are the modes of serial communication in 8051. We have four modes. One is mode 0 and mode 1, mode 2 and mode 3. And mode 0 is a fixed baud rate and mode 1 is a variable baud rate. And mode 2 is a 9-bit UART fixed baud rate and mode 3 is a variable 9-bit variable baud rate. So these are the major registers used for the serial communication. One is SCON and SBuffer and PCON. So SCON is used for controlling a serial operation mode, and SBuffer it holds the data to be transmitted and received, and PCON for changing the baud rate. So this is a SCON register, and in this SCON serial control, we can call this a serial control, and we have this is in the SFR, the special function register used to control the 8051 microcontroller serial port. It is located as an address of 98H. Using SCAN, you can control the operation modes of serial port and baud rate of serial port, and we can send or receive data using serial port. So SCAN register consists of bits that automatically set when the byte of data transmitted. So in the SCAN we have mode changing, that SM0, SM1, SM2, REN, that the receiver enable, and TB8, RB8, and transmit flag, and receiver flag. In this REN, it enables disables the reception, and TB8, RB8. It's a 8-bit mode, we can say mode 2 and mode 2 during the transmission, and the RB8 register stores the 8-bit mode of mode 2 and mode 3 during the reception data, and the TA indicates that the transmission is completed for the block of data, and RA indicates that an interrupt raised by the hardware when the complete of block of data is received. Okay. The next one is S buffer. In this S buffer, this is used for serial buffer, and the 8051 is used to hold the serial data while transmission and reception. The 8-bit register act as a temporary storage location for data being transmitted and received through the microcontroller serial port. The data returned to a S buffer is sent out serially, and the data received stored in the S buffer before being processed further. So it just stores when it's transferred, and again it stores when it received. For the purpose, we use the S buffer. And this is a Pecan register. In the Pecan, this is a Pecan register. This is a power control register which is used in the microcontroller. That is, the name suggests used to control the microcontroller's power modes located at the 87 and the SFR space. And the Pecan register is not a bit addressable. During the ideal mode, the microcontroller will stop the clock signal to the ALU. During the power down mode, the oscillator will stop, the power will be reduced to 2 volt. It's to terminate the power down mode, you have to use a hardware reset. Apart from these two, the Pecan register can also use to a few additional purposes. The SMOD bit and the Pecan register is used to control the baud rate of the serial port. So in SMOD, we can double the baud rate using the timer 1. If it is SMOD bit enables 1, the baud rate will be double, and the SMOD bit 0, it's a normal timer baud rate. Okay, and the GF1 general purpose user flag, and GF0 general purpose user flag bit 0, and PD is a power down bit, and ideal is ideal mode. Okay, as I said earlier, during ideal mode, microcontroller will stop the clock signal to the ALV, and the power down mode oscillator will stop and the power will be reduced. So this purpose, the power Pecan register used. And coming to the baud rate generation, it's very important to see the baud rate generation. So baud rate is the number of bits transmitted or received per the second, and it's usually expressed in the bits per second. So after setting the operating mode, the serial port, the program must be configured the serial port's baud rate. So the number of bits transferred per second, that is, which is only applicable to the serial port modes 1 and 3. For mode 0 and mode 2, the oscillator frequency determines the baud rate. So these are the steps to calculate the baud rate. Understand the oscillator frequency and calculate the timer frequency. So starting with the clock oscillator frequency, the standard oscillator will generate the 11.0592 MHz. The frequency divided by the 12 will get the Mason cycle frequency. The result is 921.6 kHz. And coming to the calculating the timer frequency, we will get the frequency is divided by 32 by the UART circuit, and it's giving the 28,800 hertz, the frequency used by the timer 1 to set the baud rate. For configuring timer 1, the baud rate, the timer 1 must be configured mode 2. This allows timer 1 to automatically reload the DH1. So determine the DH value. For 9600 baud rate, we use -3 for FD, that is a hexadecimal value. The specific value to achieve the standard baud rate to compatible with the PC communication and common values for the DH1. By setting the DH1, we obtain the baud rate, that is 9600, 19200, 38400, and 57600. And if you want to increase or double the baud rate, we can use the SMOD bit, which we saw in the earlier. And these are the advantage of serial data transfer in 8051. And the fewer data lines are required for reducing the complexity. And long distance, it's preferred for long distance, and it's flexible for baud rate generation. So we can generate at different baud rates. And error detection is, it's provide the parity bit, so simple error detection. And we have a standard communication support by using that serial data transfer. And we have efficient byte word transfer in this serial data transfer between the receiver and transmitter. So thank you so much for watching this video.